So, guys, welcome to 21st virtual meetup. We will be having Bharath, who is principal consultant at Thoughtworks. Perfect. Before starting, a huge shout out to Browser Stack, our exclusive sponsor for all our community events and premium sponsor for conferences. Yeah. Hi, Bharath. How are you?
Good, all well.
All good. Lovely. Perfect. Can you give us a brief intro about yourself and then we are good to go with the session?
Sure. So, good afternoon, everyone. Quick introduction about myself. So, I work at ThoughtWorks. I have a lot of experience. I won't say how many years, to be honest, just so that you don't guess my age. But yeah, so I've been in the IT industry for a while now. I've taken on a number of roles. I started off as a developer, got into testing, done multiple roles in testing. Currently, uh, lead the QA community at ThoughtWorks in India, based out of Bangalore. Have a big interest in generative AI and a lot of AI related things at the moment. So I've been writing a lot, I've been presenting a lot, and doing a lot of stuff over there.
Perfect. What will be your session about?
So today I'll present a little bit about large language models, or LLMs as they are called. So the reason that I'd like to talk a little bit about this is because of the interest that a lot of companies have in generative AIs, in AI
Yeah.
as a whole,
Yeah.
and using that in development. So the QA
Yeah.
community is it's very important that the QA community understands the engines that drive AI based applications today.
Okay. Thank you very much, Bharat. You can take over the stage.
So this is the agenda for today. So we're going to just briefly cover what a large language model is, what role does it play in an AI application, why they're important, and how does it differ from your traditional machine learning AI related applications that have been around for a while. We'll talk a little bit about how do you really choose the right LLM for you. So we'll talk a little bit about what are some of the ways in which you choose what large language model you use. And like I said, this is it depends upon whether you're a individual creating an application, whether you're an organization, whether you're a team that is dedicated towards creating something, whether you're working on an open source project versus a commercial project, or even a personal project, for example. uh, what is the kind of work that you are planning to do? Does it involve text? Does it involve audio, video? Does it involve multimodal forms of working? How do you really go about using this particular large language model, right? Where do you host it? Should you host it on your computer? Should you keep it on the cloud? Should you use a large language model that is available or open source and put it into a cloud system or a platform like a GCP, or an Amazon AWS, or Azure, for example, right? What are some of the considerations that you need to think about when you think about open source versus commercial large language models? What are some of the parameters, like the context and input length that you can provide the large language model, the model size? Should you customize an existing large language model, or should you fine tune one? uh, how do you go about that? And then how do you keep track of this particular field, right? Like, what are the ways in which you can figure out what are the list of large language models? This field is changing insanely quickly, and keeping track of even what's available today is an extremely difficult thing to do. So let's start off very quickly with what is a large language model, right, or an LLM. So we'll start talking about what it really means, why they're important, take a very quick brief look at how they work, and maybe give an example of how your typical uh, input that you provide into ChatGPT actually gives you back an output. So, what is a large language model? We've talked a lot about this so far, right? So, large language model is an AI algorithm that uses deep learning, right? So, deep learning is a form of, machine learning that utilizes something called a neural network. So, neural network is very similar to the neurons, that is in our nervous system or any animal's nervous system, where there is some kind of input that is provided, and it goes through a net or a connected set of neurons, and the output or what is being sent gets figured out, and uh, the response to that particular input is figured out as well and provided back. So large language models are essentially, huge applications by themselves today. They contain an element of networking, storage, algorithms, all of these things kind of bundled into one, so that you can utilize this neural network that is based on deep learning to provide an input and get back an output. Now, there are different types of large language models, but the way in which they are created are pretty much very similar. So they're trained, these algorithms are trained on a huge base of knowledge. So a lot of you would have read that, things like ChatGPT, for example, has been trained on all or a huge amount of textual data that was on the internet, public data, sometimes even private data that they've been able to scrape, for example. And all of this training data is provided as initially unlabeled data, and the algorithms are able to process this and figure out what to do with any input that is provided to it in order for it to provide an output. So it is able to do a large number of tasks. Some of the ones that we find very useful today is for it to be able to discern a pattern in the input that you send, figure out what is it that it needs to provide you as output, and provide you that output. So why is it different from the previous machine learning methods that we used to use before, right? And a large part of it falls primarily into three areas. So the first one is the availability of data. So previously, machine learning was primarily a supervised learning effort, and in order for teams to be able to leverage that optimally, then the data needed to be labeled, or rather the algorithms, or the systems that were processing the data that was being sent in needed to understand what the data meant to the system itself. Because of this, it was very difficult to create the volume of data that is required to be able to efficiently create a machine learning algorithm or a system that was able to provide you the kind of the kind of efficiency or the kind of usage that a large language model provides. It is very difficult to deal with machine learning as a novice in this particular field. Machine learning previously required a lot of knowledge in data science about artificial intelligence, about machine learning, and a lot of the algorithms, etc., for you to be able to even even train a model, for you to be able to even figure out how to use something. Large language models made or democratized this process quite a bit. So they allowed domain experts, they allowed people who understood how to use data without necessarily understanding how the algorithms work or how the system works, to be able to leverage the advantages of machine learning, for example. They were able to complete tasks that were relevant to them, rather than focusing on figuring out how to get the system to work. So it's very similar to a car, right? So initially, in the early days of the car, you not only needed to know how to drive, you also needed to understand how cars work, because they frequently broke down, because they frequently needed to be coached into working. However, as cars became more advanced, now the focus is more on driving and making the car more optimal to get you to transport faster, to transport more efficiently, to transport bigger and bigger loads, rather than worrying about how the car actually works. And you have a lot of people today who have zero idea about how the combustion engine works, how the the light works, the horn works, etc., but they're able to use the car perfectly in terms of being able to get something done with it, right? So that is one of the biggest reasons why large language models have been a huge step forward in artificial intelligence, and why organizations, people today are able to use it as part of their daily routines, as part of you know changing architectures in terms of applications themselves. So previously, applications were told what to do; they would do that. But now there is a lot of intelligence in the application being able to adapt to different types of inputs, to different types of stimuli, etc., and provide you more contextualized output, more efficient or more personalized output that you can use to do different things. So how do they actually work, right? So if you think about what a large language model is, as I've told you, it's a deep learning network that takes in an input and provides you a result. And the large language model itself is trained on a huge set of data, right, that is relevant to that particular large language model. But if you take a deeper look at what a large language model is, a large language model is basically a tree or a graph of nodes that have something called weights and biases. So what a large language model really does is that when it gets an input, it uses that input to predict what the next part of that output should be, right? So it basically contextualizes or tries to understand what inputs you've given, predicts the next output that needs to be provided back by the system, figures out what is the best output, because it gets a number of different outputs that it creates based on probability trees that are created by the algorithms that power the large language model, and then figures out what is the best possible output that can be returned to you. So when you actually provide an input to a large language model, it is actually predicting an output for you. A lot of people, feel that large language models are able to process and they understand the input that you give them, which is not true. The large language models are not sentient in any way, right? So they actually just do pattern matching to kind of understand what is the input that you've given. They try to predict what is the best pattern that is a response to the input that has been given, and give you back that output. So if you take a simple example like the cat sat on and ask the large language model to provide you a response to that, the first thing that it would do is convert the input that you give, the words that you give, into vectors or numbers that it is able to understand. So there are algorithms that convert these into numbers that make sense to the large language model. And all of this is, by the way, very simplified, so I'm just trying to skate over it at a very high level. Please do go and look up uh, more details in terms of how the algorithms work if you're really interested. But at a very high level, the numbers then get sent to the neural network that is within the large language model. A set of predictions are given as outputs. It chooses the best fit, or the best depending on the algorithm that is used to figure out what is the best response. It figures out the best response and gives you back the response. So the reason that I'm getting into this is for you guys to understand that large language models are far from perfect in terms of the responses that they give. Sometimes they're very good at giving you responses that look great, that sound great, but you need to understand that these are actually predictions that are provided by the large language model, and they are not written in stone. The next time you run it, it could change completely based on the input that you give. So what are they really, how are they really used today? So there are a large number of use cases which are, to be honest, very uh, just limited by your imagination as of today, right? But you can broadly categorize these into these categories. So the first is being able to augment or automate parts of the work that you do. Second thing that I find especially generative AI to be very useful is to be able to ideate anything, any topic, any ideas, any process, etc. uh, Based on the input that you give and the context that you give it, it is able to come up with a lot of great responses. The next great use case is being able to personalize or customize things to your needs, right? So this could be domain based. So let's say if you're from the chemical industry, and you have a large language model that knows how to respond or understands the way that inputs and outputs work from a chemical industry perspective, you can personalize or customize your outputs based on this. You could use it to analyze a lot of data, for example. So summarization, classification, being able to come up with examples of new examples based on what you've already created, new patterns based on existing patterns is another great use case that you can use it. So from a QA perspective, right, where can you use this, right? So there are a lot of amazing ways in which you can use this. Test data creation, for example, synthetic data, being able to analyze or create root cause analysis, being able to do code reviews, what the previous session was about. There are great tools to be able to create code for you. There are great tools that allow you to, generate documentation, to be able to create, templates or formats for you to use. So there's a huge number of applications in terms of where large language models can be used as of today. So this is an application that I built. Just wanted to show you, where a large language model would fit into, traditional architecture. So you have a use case which starts with an input from a user or a system, and it goes through a number of things. So the OpenAI icons that you see on the screen are where the LLMs fit in. So this is a foundational large language model, which is basically a pre-trained model that OpenAI gave to me. I didn't do anything on top of this. I'm just using it out of the box. So I use this to take in an input. I feed in a number of documents, and I use something called a vector database to store chunks of that huge document. And I'm using this large language model to help me query this document and chat with the document in a sense, right? So large language model is kind of the logic layer of this particular application. It is something that is used in between the input itself, so the UI, and the business logic of this. I also use reinforcement learning in this particular case to make uh, the context that is provided to the large language better, which makes the responses that I get better as well. So, we've talked a lot about what large language models are, right, and stuff like that, and potentially where they can fit into, an application. They can actually be both within the application, within the black box of the application, or sit externally and be something that can act as a third party, API or a call that is made to make your existing application better. People currently use it a lot, for chatbots. They use it a lot for customer service. They use it a lot in terms of generating ideas, being able to create new proposals. So there are companies that, for example, have fed in all their existing business proposals, and based on the inputs that they give, they're able to get back a proposal that is almost 80% complete, so they can kind of just finish it off a lot faster. So it's very important to understand that LLMs are the way forward. And now that we understand a little bit about how they work, we probably need to understand how do you get to choose these as well, right? So what are some of the factors that go into actually choosing these? And the primary factors that, in my opinion, that are very important as of today are: one, you need to really understand what is the outcome of the application that you're trying to create. What is the purpose? What is the goal of the application that you're trying to create? Because without understanding the goal, it's kind of pointless to go through this entire exercise. The large language model that you choose, they can be general large language models. They can be fine-tuned large language models. They could be contextualized large language models. They could be large language models that can sit in your system externally. It's very important for you to understand what is the purpose of the application that you're creating with this large language model, to kind of understand what needs to be done with it. The second is, what is the work that you're planning to do with the large language model. Large language models are text based, they are image based, they are multimodal based, which is audio, video, and pretty much any other form, right? So choosing the appropriate large language model that can handle all of these things is very important. You also need to understand whether your large language model needs to be online, or is it okay if it is offline? Uh, does it need extra plugins? Does it have extra plugins? What kind of work are you planning to do with this, right? Are you planning to generate something new, in which case a generative AI LLM is great? Or are you planning to use it for pattern matching, classification, things like that, in which case a more traditional large language model without generative capabilities might be better for you? You need to understand what is the scale of your application. Is it personal, for personal use? Is it for a small team? Are you creating a plugin with it? Are you creating a small utility with it, which will be used by a few people? Or is it going to scale to the entire organization? So the choice of your large language model, where you host it, where you use it, all of these things are completely dependent on this. And of course, you need to understand what resources you have. Money is a big factor, right? So there are free large language models, but you also need to understand what kind of infrastructure do you have, what kind of expertise do you have at your disposal to be able to leverage these large language models. How much work are you willing to put in? How much time versus output do you really get back for this? Performance and latency are very important as well, because there are large language models that are amazing but very bad in terms of performance and latency because of the size of these large language models. Is performance important to you? Is your application development speed important to you? Is your go to market important? All of these again play a part in whether you choose, let's say, an open source large language model which is free and perhaps easy to use, or do you prefer a commercial one which is hosted somewhere, which is curated for you, which has customer support, for example? You also need to understand what are the restrictions that prevent you from using a particular large language model. Things like your data privacy, data security, whether you are allowed, to take the data that you're providing to the system outside of your network, for example. Is your organization okay with it? Are the governance policies of your organization or the country that you're operating in, or where the application is going to be used, are they in alignment with that? Because all of these things really matter and need to be thought of before you actually decide how you actually create the AI application, how you actually choose the large language model that you use. So next is the nature of work that we talked about, right? So there are large language models that are specialized towards special things, or there are large language models that are more generic. So ChatGPT, for example, tends to be a more generic large language model that allows you to do a lot of these things. Whereas something like a CodeBot, for example, is something that is specific for code. A Mid Journey, for example, is specific for image-based work. Whisper, for example, that is provided by OpenAI, is specific for speech. Uh, so you need to understand there are large language models today, like Llama, for example, that can do a couple of these things. They can handle images. They can also handle uh, text, for example. So do you need that speciality? So understanding whether you're going towards a more specialized large language model versus a multimodal one, makes a big difference to you as a QA or you as a developer, because you need to understand all the vagaries and all the changes that come in with the kind of work that you're trying to do. And the heart of this particular application, which is the large language model, affects the work that you do by a great deal, right? So you need to understand what are the limitations, what are the abilities of the large language model that you're using, to be able to plan, to be able to test, to be able to leverage this to a good extent. So, we talked a little bit about hosting previously, and like I said, you can have self-hosted or in-house large language models, or you could use them in the cloud, right? But what are some of the considerations that you need to think about when you're talking about hosting? And this kind of goes back to the choice of the large language model we talked about a little bit earlier. The most important thing is what kind of infrastructure do you need for your large language model? Is it okay if you want to run it on your computer? Like, for a lot of personal work, for a lot of small applications, for a lot of applications that do not require a lot of computational power, it's perfectly fine for you to be able to host it. You might want greater control over the inputs and the outputs that your large language models give, in which case it's easier for you to host it in a location that you can figure out, right? Even if you're not hosting it on your computer, if you're hosting it on a service like SageMaker from AWS, for example, where you can choose what large language model you want to use, that is something that you really need to think about. You need to think about, how much computational power do you need, how much bandwidth do you need, how much performance do you need, and things like what kind of scaling do you need, for example, to be able to think about where you want to host it, right? The second thing, which is again very important, is data privacy, security. Are you allowed? Does your organization or does the application that you want to create allow you to send data out of your network? Does it allow you to connect to external systems to be able to do this AI, the processing that can be sent back to your system? If it does, great. If it does not, then you really need to be careful about where you host this. So a lot of people, for example, are gravitating towards Microsoft's OpenAI service, which promises that the data that you use, that you create, that you consume, and that you generate will not leave your network. So companies, for example, enterprises that are planning to create AI applications, even if it's for internal consumption, need to be very careful about where they host this, right? Again, performance, latency, very important, because if you have a cloud-based system, uh, it's probably way more performant than what you might be able to do as a self-hosted system, right? You might not have the required storage, the bandwidth, the networking latency to be able to create a performant, usable system. So that's something that's very important for you to think about in terms of where you host it. The next is expertise, right? Can you do ML ops? So machine language operations, right? Like DevOps. Now there's ML ops. As you keep developing, with large language models, are you able to keep up with the pace of development? Are you able to figure out how to deploy something, how to test something? How do you train your existing large language models? How do you do reinforcement learning? How do you think do things like retrieval augmented generation, for example? Given all of these things, is it better for you to use a hosted large language model like your chat GPT, for example, or does it make sense for you to use a llama hosted on your machine and be able to do something with that? If you have the expertise for it, you have the aptitude to learn or the want to create something on your computer with granular holding on top of that, then please go ahead and do that. But if you don't, then probably makes more sense for you to find a hosted large language model and use that rather than trying to do it yourself. And the last and perhaps most important criteria in this whole thing is, do you have the money to be able to host something on your own? Do you have the required computational power, the storage power? Do you have the aptitude to create something? Even if you are planning to go for a hosted service, ChatGPT, for example, hosts it and they charge you $25-30 a month to be able to use their APIs or to use their chatbot, for example. Are you okay with the free service, or do you need the extra features that are provided to you by the paid service, for example? So similarly, you have Google providing Vertex, different types of Vertex solutions, which more and more get better and better as you pay more for it, right? So do you need a paid solution? Do you need a open source solution? Do you need a free solution? Do you have a freemium solution? So for example, you might pay nothing for the base foundation, but you might be paying for the plugins that sit on top of the large language model, for example. So all of these things are very important to understand. How do you really host it? So here's an example that I found on the internet. So here are some of the things that you can think about. So if you need more privacy, you might think about self-hosting it. You could either put it on your computer or you could put it in, a closed network that you might control. Uh, the speed of development that you are planning to, create an AI application on top of the system would dictate where this is hosted. So if you really need fast development, then choosing something like a hosted system like an OpenAI GPT would be better. If you're looking at initially low cost, you might want to choose a hosted system, whereas versus a longer term uh, uh, prospect where it might be cheaper for you to host something, right? Do you need minimal infra setup, or do you already have the existing setup and the resources to create the setup that you need to host a system? Because hosting these systems are not cheap, but going forward, as computation, GPUs and all of that get cheaper and cheaper going forward, it might make more sense to gravitate towards self-hosted large language models rather than using hosted ones, right? So if you need a lot of control, you need to not have external dependencies, then yeah, again, choosing a self-hosted large language model is very important. If you're very picky about the quality of the responses that you get back from your large language model, as of today, unless you've done a lot of fine tuning, unless you've contextualized your large language model, or you're able to create a system that has enough context setting or reinforcement learning that your self-hosted or open source large language model is great, it probably makes more sense to use a top quality large language model. So we'll talk a little bit about how you can do this comparison of what is a good quality, bad quality a little bit later. But this is how you would get started with something like this. So now that we've talked about hosting it, do you go for an open source one like a Llama or a Dolly, or some of the other ones that are out there today that are provided by organizations where you can customize it, where you can work on top of it, uh, you can self-host it on your computer or on your system to be able to create the kind of work that you need, versus going for a commercial software like the chat GPTs, the Vertex or the Palm APIs that are provided by Google? Or do you use something like a Claude, for example, which is a mixture of open source versus commercial? The way that you decide on this is very similar to how you would do a build versus buy for, let's say, an automation software, for example, right? Do you choose to go for uh, you know uh, open source tool like Selenium, for example, or do you pay for, let's say, Cypress and get the premium features that Cypress provides for you to be able to do UI testing, for example? A large part of it comes down to initially the resources that you have, but it also comes down to how much expertise do you have within yourself to be able to use or leverage the open source system. Are you okay with limited community support, or sorry, limited customer support for your system? How quickly can you create something with your out of the box system? How important is that for you? How important is privacy for you? How important is control over the system for you? All of these things play a big part of how you choose whether to go open source versus commercial. The next couple of sections are related to the properties of a large language model, right? So we talked a little bit about a large language model, how it works. It basically starts working for you when you send an input to the system. Now, different large language models, take different sizes of inputs, and why this is very important for a large language model, especially from a QA perspective, from an application usage perspective, is that the length of the inputs that the large language models can handle allow you to better utilize the large language model. The more input you can provide to the large language model, the more context you can set to make the large language model understand what you're trying to do. So let's say if you're trying to send one entire repository of code to your system, uh, if you're able to do it in one shot, your response from the large language model would be infinitely better than if you have to keep sending it in chunks. Uh, and the context that you can set, the memory that the large language model has in terms of processing the inputs that you have, the better job it can do at pattern matching, the inputs that you give. So choosing large language models that allow you to send larger input, allows you to do more with the large language model. So MPT, for example, is a large language model that claims that it can take up to 65,000 tokens or 65,000 vectors, that numbers that we talked about, right? To be able to do something with that. Now, I've worked a lot with GPT recently, and the although they say it can take up to 32,000 tokens, it probably does not do that because of the way that it converts your input into tokens. But having a large language model that takes in large inputs can give you better outputs. Of course, you are limited by the size of large language model that you use, based on the money that you can spend, based on access, based on things like your privacy and other restrictions that you have in terms of what you can and cannot use. So consider this to be a very important part of choosing large language model. So uh, typically, the bigger the input size or the context size, the better the large language model in terms of providing you outputs. So this should be a very important consideration or a property of how you choose a large language model. The next is model size. So typically, this talks about how you train the large language model, how much training data has been used to create the neural network within the large language model that we talked about. And the rule of thumb as of today is that the more number of parameters, or the larger the training size, the better the predictions the large language model can give you, which means that it does a better job of trying to do what it needs to do. Now, depending on what you're trying to do with the large language model, the size of data that you provide the large language model changes significantly. So, if you have a contextual or a very purpose-driven large language model, like if let's say it only looks at code, or it only looks at images, or it only looks at a particular type of work, your large language model would typically tend to be much smaller than more generic large language models like your GPT-4, for example, which can handle a large number of use cases in terms of what you want to do. But typically, the larger the language model, the better that it can do. And the reason why GPT-4, as of today, in most leaderboards would be number one is because of the size of the data that it was trained on. So since the data that it was trained on is huge, it is much more accurate or much better at being able to provide you the kind of outputs that you are looking for. And this particular page has many different large language models that have been evaluated versus each other. So when you are doing your evaluations in terms of large language models, or your teams are doing these evaluations, you might want to keep this as a factor. So the larger the number, the better it actually performs. The next is something that we probably need to take one step back to understand a little bit. So I talked about large language models and how they typically work. So the process of creating a large language model, uh, like I said, involves being able to train the algorithms to create your neural network that does the predictions that we talked about, in a way where you are able to take in a large number of training data, and being able to create graphs which allow you to do predictions. So this is an extremely intensive computational process which requires a huge amount of infrastructure, a huge amount of data, and a huge amount of expertise to create a large language model in the with the parameters that we talked about, right? So these are the parameters. So all the training data creates all of these parameters, and creates a graph which allows you to create predictions when you give it an input. Different large language models have different number of parameters, and this creates something called a pre-trained or a foundational large language model. That is something that you get out of the box. So when you use a chat GPT, for example, for the first time, you're using the out of the box version of chat GPT. However, as you keep using, let's say, in that same chat of a chat GPT, as you keep using that, you'll notice that it keeps getting better and better at responding to you. So you're giving it context in terms of what you want it to perform or what you want it to do. So the more examples they give, the more uh, data that you give it in terms of what you're looking for, the better or more contextualized the responses that it gives you becomes. Now this is a way, that you can do it on the run or in a dynamic way. However, when you think about large language models in a bigger sense, you need to fine tune or train the large language model to do something more. So basically, the way that or what fine tuning really means is that you give inputs of examples of inputs and outputs, and you say you give a huge number of inputs and outputs, which says that if I get this kind of input, I would expect you to give me Y kind of output. And by providing this, you are fine tuning the large language model to be able to give you better and better results. So for example, if you provide, let's say, a list of 100 inputs in terms of let's say uh, things that you want the large language model to do. So let's say if you give it a city name, you would, and your output looks like the state that the city is in, the country that city is in, the area code in terms of telephone area code that that particular city has, and the weather of that city for a particular day, for example. The next time you type in the name of a city, it will give you all of that output back if you provide it enough examples where it is able to figure out that if you are trying to give x amount of x type of input, it gives you y kind of output. So we talked about one organization being able to create proposals, business proposals, for example. So that's what they did. They fine tuned an existing pre-trained large language model, uh, gave it examples of inputs, and said that this is the kind of proposal that would come out as an output for the inputs that we're giving you. So the next time they're able to give an input, it would use all of this pre-trained data on top of the existing pre-training that it has, and give you back a more contextualized answer, or give you back, in this case, a better proposal that meets the kind of demand that you need. The next part that a lot of companies are working on, you cannot really do this 2B with OpenAI, for example. You can do 2A with OpenAI, uh, is being able to not fine tune the entire model. So fine tuning is a very expensive exercise and something that a lot of experts prevent you from doing because of the cost associated with creating the large language model. One, it is very expensive to create the training data to fine tune the large language model. Second, your costs associated with using a customized large language model versus a vanilla or a pre-trained foundational model is exponential in terms of difference of resources. And you also need to uh, think about the quality of what it actually does to your foundational large language model, right? It kind of changes the way that it works completely. So something called parameter efficient fine tuning is something that a lot of people are working on as of today. So we talked a little bit about the neurons in the neural network that exists. So they contain something called weights and biases. So for an input that comes into the neural network, based on these weights and biases, they provide you with an output. So you can actually, rather than giving inputs and outputs, you can directly go and change the weights and biases. Now, as you can imagine, this requires a lot of extensive knowledge of how the algorithms of the large language models work, and being able to just go and change the relevant ones is something that requires a huge amount of expertise. So, but by doing this, you don't need to create that huge amount of data to be able to create a large language model. You can just go and tune the parameters that you want for your large language model to become much more efficient. So we've talked a lot about these large language models, how to use them, what to do with it, where they fit in, etc. But this field is changing so rapidly, it's very difficult for you to keep track of what's available to you as of today. uh, New companies or existing companies come out with iterations of existing large language models, or come out with brand new large language models themselves. So the first thing to understand is what are a list of all the most used or the most important large language models as of today, right? Both from an open source perspective as well as from a commercial perspective. And the second aspect is being able to use at least base comparisons between at least two models. So I found this particular link to be very useful. Uh, so if you go here, you should be able to see a huge, constantly updated list of the most used or the best known open source and commercial models as of today. The second one are leaderboards. So there are actual evaluations that are or tests to test out, large language models, and this is where it's very useful for testers, especially to understand, how these large language models are evaluated versus each other. There are a lot of different leaderboards that people have. They are based on different tasks. They are based on different prompts or the inputs that you provide the large language models based on the outputs that they give, and all of these are typically benchmarked versus one benchmark large language model. And they see how do they perform versus the benchmark large language model in terms of what is the input versus the expected output. So here's a few leaderboards that I found. The most used, the best known one is the Open LLM leaderboard by Hugging Face. So Hugging Face is an authority of all things, generative AI based or AI based. So please do check out Hugging Face if you haven't already. And a couple of other ones that I find useful, like Alpaca Eval is a great place for you to get some quick information. I code a lot with Streamlit to create UIs on top of large language models, or create an interface on top of large language models. So their leaderboard is pretty helpful as well, because from a perspective of connecting or being able to leverage or use certain large language models, you will be able to get a good sense of what is easy for people to get started with, and how do you actually go about getting some test code, or simple examples of how to get started with this entire process. So this is a kind of summation of what we want to talk about, right? So as I said, we talked about what large language models are and how do you go about evaluating how best to use these. So as I said, it's very important for all QAs, all developers, to understand the process of choosing these, because going forward with the number of large language models that are coming out, the way that you use it, the kind of language model that you use, and how you need to actually go about leveraging it is going to be based on how well you understand this evaluation process. We're still at a very beginning stage in terms of all of these, and AI applications are largely experimental even now, but it's coming very soon, and the pace of development of an AI application is about 10x that of a normal application. So we really need to be on point in terms of understanding how these work, and why these are important to us. So I'm happy to take any questions if we have any, and we can probably take a look at that.
Yeah, Bharat. Few questions. The first question is, sorry, this is not the. Can we integrate OpenAI's API with other LLMs with LangChain in case how it works behind the scenes?
So LangChain is not an LLM. It's a library. Uh, it is a library that allows you to leverage or break down huge amounts of data and do different things with it. But yes, you can definitely use LangChains with uh, OpenAI APIs. And that application that I gave you an architecture diagram of actually uses LangChain to chunk the data into smaller pieces and be able to use that for searching and all of that stuff.
Okay, there's one more question. You spoke about test data generation. Any use case to share? Also, predictive analysis is also talked about nowadays. What is your point of view on that?
So I've that's actually a huge topic by itself in terms of what are the use cases that you can use for generative AI. Actually, one of my previous talks with you guys dealt with that. Uh, but let's take the four primary. Uh, use cases or categories of use cases that I talked about, right? So in terms of augmenting or automating the kind of work that you can do, test case generation, synthetic data generation for your performance testing, for your integration testing, for your even just for your unit testing, for example, can be done with something like generative AI, for example. If we talk about ideating, uh, I've written a lot of articles about it. I've put it on LinkedIn. You're welcome to look it up if you'd like, to go into more detail. That goes into a lot more detail than what I'm talking about right now. But if you're thinking about ideating, for example, coming up with a strategy for a data testing, for example, coming up with a test strategy for security testing of an application, coming up with an outline in terms of how would you communicate between the business stakeholders versus you, to get the right details required. I've given an example of performance testing and all the various things that you can do with ChatGPT, for example, to come up with templates, to use those templates uh, in my LinkedIn articles. So please do look at that. From a personalization or a customization perspective, again, synthetic test data generation, but also, creating code, let's say translating code, for example, right? So you might be somebody very good at JavaScript, you don't understand Python. A lot of code is being written in Python today. You can use these large language models to translate the code from JavaScript to Python, for example. You can get code that is very similar to the way that you write code, for example, right? If you're able to provide enough examples to the large language model in terms of what an input and output should look like, you could get code, if your company has standards in terms of what code generation or documentation for code looks like, for example. All of these are examples of customizing the large language model to be able to uh, create output that is very similar to what your organization requires. So if your organization requires data in a particular format, you can customize or fine tune or coach your large language model to be able to do all of these things for you. From an analysis perspective, we talked about root cause analysis. You can, if your large language model is safe to use in terms of data privacy, security, etc., you can send it your issues and get it to provide you, get it to provide you a root cause analysis of what is causing the issue. And the more data that you provide it in terms of examples, in terms of fine tuning, etc., it can do a really great job of inputs and outputs, for example. Maybe we can have another session in terms of applications that are actually built using these. I'm happy to, or even if you guys want to reach out, like I have given examples uh, on my LinkedIn articles or other presentations. Please feel free to check them out. uh, in terms of analysis, you can give it code and ask it to explain that code for you, right? So things like Copilot and aider, aider, OpenAI, Bard, all of these do a great job of explaining code to you. For example, you can use it to learn. I use it a lot to learn, for example, something that I don't know well. uh, Again, this comes back to the personalization, customization aspect of it. So let's say you want to, I've not used Playwright. So if I want to use Playwright, this is a great place for me to use, create small snippets of code so I understand how to make it work, and perhaps build on top of that, rather than, I mean, I don't encourage copy pasting directly, because like I said, large language models today still have a lot of issues related to the inputs and outputs that they give. So, but getting started with something, getting started with boilerplate code, uh, this is a great way for you to be able to use and get started or augment the work that you do, make yourself a lot more efficient. So these are all examples of use cases that you can use. So predictive analysis, as you mentioned, Kunal, that's also something that I'm looking at as of right now. So I'm creating an article for it, for a blog. Uh, Please keep a lookout in terms of where you can use it, how you can use it, etc. So I'll be going into a little bit of detail over there.
Yeah, perfect. Skip is asking, can you show me one example of
Test data creation with minimal precise prompt. Example, to create a random email address which covers can be combination of multiple commonly used large spoken languages in the variable, etc.
Sure. So, if you want to see an example, so the best way to get started with something like this is to use a general, uh, you know, application like ChatGPT, for example, to be able to, just get started very quickly for you to understand what kind of inputs you need to give, what kind of outputs you need to get back, etc. Right. So I've actually created a generative AI series that talks a little bit about this. Maybe I'll present uh, the screen over there. Uh, just hold on one second. I'm just trying to pull up an example of what I'm talking about over here. Right. So if you look at a LinkedIn article that I've written, so this is about using bad quality test data or synthetic data to test your data pipelines. Right. So if you are doing anything related to data quality management, etc., testing your data pipelines is very important. So these are systems that take or ingest data from one source or many sources, and kind of either dump it into a storage system, or they do some transformations on top of that and put it somewhere which can be used further. uh, so it's not only important for you to test these with good data, but it's also very important for you to use bad data to test whether the transformation rules, the anonymization rules, all of these things matter a lot, right? So in this particular article, I've gone through a number of different prompts, which creates bad quality test data for uh, a system that pulls in inventory related data for a product or a set of products from a system. So it's very important for you to provide the kind of data that you need, but also kind of give it rules in terms of saying how much is of data should be good, how much of data should be bad, what kind of realism do you need with this. Should it be based on a country, city, uh, should the names, for example, be based on certain brands. You can customize it to that level, right? And I've given examples of prompts and what the inputs and outputs look like. So you're welcome to follow these. Like I said, I've written a full series of things on these, uh, and these have all the examples that you're asking for. So here are some of them. So I've been writing a lot, and you're welcome to follow these if you'd like.
Perfect. I hope skip you spoke about test generation. Uh okay. Yes, we have taken that question. Perfect.
Guys, I have a very small plugin. Okay, so we are having our own course on generative AI for testers. Okay, so where you can learn how all these LLMs work and how you can use it as a tester in your daily life. Thank you very much. Thank you very much, guys. Guys, do join the Discord community. You guys will get all the links in all the mails you guys get. Okay, do join the Discord community also. Perfect. Bharat, any closing thoughts?
No, so I hope it was relevant to you folks. Might be a little future facing, rather than perhaps things that you can do directly today. But these are definitely things coming your way, and everyone should be aware of the kind of applications that are being generated or created today. It's still in the
Yeah.
experimental phase. It's a very exciting field for
Yeah.
people to get into. So this goes beyond our typical automation, performance, security, etc., and is
Hmm.
something that has a lot of unknowns. So a lot of people can contribute over here. A lot of people can
Yep.
become. If you want to become an SME in this particular area, this is a great time to jump into something
Hmm.
like this and kind of set
Yeah.
yourself apart, because It's not an area that a lot of people have expertise in. So,
Yeah.
but the great thing about this is that it's very democratized, and the more effort that you put into it, and you don't need anyone to kind of coach you into this, right? You can actually use the LLMs themselves to learn about all of these
Yeah.
things. So
Yeah.
it's a great way for you to learn all of these things, and contribute over here. So I really hope
Yeah.
that this was a good introduction to this. We've barely
Yeah.
scratched the surface, and each of the topics that I talked about are a separate topic of their own. But
Yeah.
keep
Perfect.
learning, and be hungry, be foolish.
Yeah. Thank you. Thank you very much, Bharat. Thank you very much. Thank you very much, Bharat, for taking our time. Yeah. Bye, guys. Happy testing.